Alright, we're going to go ahead and get started with Lesson 5 on ions. This is just an introduction to ions and what they are. We'll be spending quite a bit of time throughout the entire year discussing ions and using them. So this is just the basics. To get us started, we're going to look at three important definitions of ions. The first one is exactly what is an ion. So by definition, an ion is an atom with a charge. Ions form from atoms or from groups of atoms by transferring one or more electrons. So what we're dealing with here with ions is charged atoms. Atoms that have not the same number of electrons and protons. In this case, the proton number is not changing, but the electron number is changing because we're going to lose or gain electrons. Alright, so cations. So cation by definition is a metal atom that has lost one or more electrons to form a positive charged ion. Whereas an anion is a nonmetal atom that has gained one or more electrons to form a negatively charged ion. So let me kind of give you some examples here. So for cations, remember cations, they're going to lose their electrons, and they're metals. Metals have the tendency to lose their electrons. So let's look at sodium for example. Sodium, being a metal, has the ability to lose electrons. And sodium has really the desire to lose one electron. And so when it does so, it's going to form a positive 1 charge. Positive 1 indicating that there are more protons, one more proton to be exact, than it has electrons because it's lost one. Let's look at magnesium. Magnesium as a metal has the ability to lose 2 electrons, and so it's going to form a 2 positive charge, meaning it has 2 more protons than it has electrons. Let's look at something like aluminum, Al. Aluminum has the ability as a metal to lose 3 electrons, creating a 3 positive charge. Again, the positive charge 3 tells us 3 electrons has been lost. Therefore, we have 3 more protons than we do electrons. Okay? So those are cations. What about some anions? Well, anions, as we just mentioned, by definition, they're nonmetals, and they have the ability to gain electrons. So, for instance, let's look at fluorine. Fluorine has the ability to gain 1 additional electron to become a 1 negative charge. The 1 negative referring to the fact that it has an extra electron now, so it has more negative charge than it does positive charge. Let's look at oxygen. Oxygen, being a nonmetal, has the ability to gain 2 electrons to make it a 2 negative charge, meaning that it has 2 more electrons than it does protons. And finally, nitrogen. Nitrogen, being a nonmetal, has the ability to gain 3 electrons to make a 3 negative charge. Therefore, it has 3 more negative charges than it has positive charges, giving it overall a negative 3 net charge. All right? So those are the anions. Now let's take a moment and fill out this table and practice this a little bit. Okay? Now again, we're just making this really easy to start with. Eventually, you're going to be able to predict what the charge on the atom will be based on how many electrons an atom will gain or lose. And you're going to learn that. But for now, let's just look at these ions. Sodium ion, again, has a positive 1 charge. And so we're going to go ahead and indicate that in our table under ionic charge, a 1 positive. It is a cation. I'm just going to put C real quick for cation. It has 23 neutrons and protons. That's its mass number. So if you use the periodic table, you will see that sodium has 11 protons. That's its atomic number. So 23 minus 11 should be 12 neutrons. And then because it's lost an electron, remember in atoms that are neutral, they should have the same number of electrons and protons. But because this is a charged atom, we no longer have that. And so therefore, we have one less electron than protons. And so there should only be 10 electrons for our sodium ion. All right, chlorine. Chlorine is an anion. It has a -1 charge. So A for anion. If you look at the periodic table, it should have 17 protons. So 35 minus 17 is 18 neutrons. We have gained one more electron. So if we go from 17 electrons to 18 electrons. Sulfur has a 2 negative charge. It is also an anion with an atomic mass number of 32. The number of protons sulfur has is 16 on the periodic table. Therefore, 32 minus 16 gives us 16 neutrons. And since we've gained two additional electrons, we should have 18 electrons total. All right, aluminum. Again, aluminum is a metal. It's going to lose electrons, in this case 3 electrons, to give us a +3 charge. It is a cation then. It has a total of 13 protons. So 27 minus 13 gives us 14 neutrons. And since it's lost those 3 electrons, it can only have 10 electrons total. All right, hopefully you're getting the idea here. Okay, magnesium. Magnesium is going to have a 2+ charge. It is a cation. The periodic table tells us that magnesium has 12 protons. 24 minus 12 is 12. So it has 12 neutrons. So lost 2. It's lost 2 electrons. So therefore, it can only have 10 total electrons in those electron shells. Okay, phosphorus. Phosphorus is a nonmetal. It has the ability to gain 3 electrons to form a 3 negative charge, as indicated there. It's an anion. Its mass number is 31. The periodic table tells us that it has 15 protons. So 31 minus 15 is 16. 16 neutrons. Now, we've gained 3 electrons in our electron shells. So we've gone from 15 electrons now to a total of 18 electrons. 15 plus 3 is 18. All right. Okay, now the last two, instead of putting a charge there, it has a Roman numeral. Now this can be typical for metals, specifically transition metals. And hopefully by now you know where the transition metals are on the periodic table. They're in the center. All right. Transition metals can have more than one charge often. And so we often use Roman numerals to indicate its charge. And so since iron is a metal, it must be a cation. So it's going to lose 3 electrons to form a 3 positive charge, indicated by the Roman numeral 3. Again, the 3 in the Roman numeral stands for 3 electrons that have been lost. Right? It will be a cation. Mass number is 56. Periodic table tells us that iron has 26 protons. 56 minus 26 is 30 neutrons. And since we have lost 3 total electrons, it will now only have 23 electrons in its electron shells. Copper is copper 2. Okay, that means it has a +2 charge, indicated by the Roman numeral. It's a cation. Mass number is 64. It's going to have 29 protons. 64 minus 29 gives us 26. 35 neutrons, and we lost 2 electrons, so that's 27 electrons in its electron shell. So hopefully we kind of get an idea of how this works. Now, when we finish up wrapping this idea, I'm going to show you something here. Okay, here we got this whiteboard. Oops, let me see if I can erase our work here. All right, now, as we said, cations lose electrons, metals. So let me go back to magnesium really quick. Magnesium has 2 electrons that it can get rid of. Magnesium has an atomic number 12, and in this case it has a mass number of 24. That's the isotope that we're going to look at. All right. So magnesium is going to lose 2 electrons, and so that's going to form, still we have 12 protons, and our mass number did not change, but now we have a charge. Because magnesium lost 2 electrons, it's going to have a positive 2 charge, indicated by there are more protons, 2 more to be exact, than electrons. All right? And so you can kind of look at that. This has 12 protons and 12 electrons. And then when it's lost those 2 electrons, we have still 12 protons because it's still magnesium. And now the loss of those 2 electrons is this 10 electrons overall. Okay? So I'm really hoping that you kind of see this. Let's look at one more example using a nonmetal. All right, so let's say we have, let's do sulfur. All right. Now sulfur basically has an atomic number 16. It has a mass number of 32. So total, it has 16 protons and 16 electrons in its neutral form. But sulfur has the ability, oops, we actually should try it the other way, has the ability to gain 2 electrons. Okay? It can pick up 2 electrons. So that creates a sulfur ion with a 2 negative charge. Still has the same mass number and proton number. All right? Oops, 32. Let me write that. 32 and 16. Okay, so still has the same proton number of 16, but now it has 2 more electrons, giving it 18 electrons total. All right? So that's kind of how anions and cations work. All right? So that is all I have for right now in this lecture video. Please study this really closely so that you have the basics down of ions, and be ready to take a quiz in class over it. Okay? So that is it.